Good morning, geometry class. Hey, first of all, I am so incredibly proud of you guys for the work that you did last week on those video assessments. I know just from some of your comments in the discussion board that maybe that wasn't easy, maybe it was a little scary, maybe I was asking a little bit more of you than I have asked in the past, but I have gotten a lot of great submissions. A lot of you went above and beyond, and know that I appreciate that, and I see you, and I see the work you're putting in. We are going to continue our study of shapes this week, and we're going to kind of do that in two ways. We're going to have a little notes section of this week, which you're going to figure out today. You are also going to be doing a Kahoot, which hopefully brings some fun into all this goodness. And then finally, you're going to participate in a little competition. Now, that competition is up to you, that's what I meant to say. It's up to you if you want to participate. I would love it if you did. Our top 5 winners will get candy, so you can check that out on Thursday and see what I will be asking of you. So, to start with today, we're going to be talking about volume. Volume is this whole idea that I can figure out how much space is in the middle of something. So, as I'm looking at, a prism, or if I'm looking at, in this first one, I'm looking at this cake. All right, there's this nice cake. I'm saying, how much area do I have inside of this cake? Volume is something that takes part in our everyday lives because volume represents more than just surface area. It represents how much. And I think that's so important because that's what we are all about as consumers. How much, if you even think of face wash, how much face wash is inside of there? If you think of, I don't know, you could probably think of 1,000 different things. How many chips are in the bag? What's that volume inside of there? Did they fill the bag all the way up? Or are they really cheap and it's like a quarter full even though the bag looks huge? Volume impacts us every single day. Now, the nice thing about volume, similar to surface area, is we just have a lot of formulas that we can kind of look at. Now, if you want to take these notes, you can kind of do it however you want. But if you need to take it on a separate piece of paper, I'm okay with that. Just make sure that this part is really clear so I can see that you're actually looking at it. So when I take a volume of a prism, the volume of the prism equals the area of my base times my height, which is h. So that's a really simple volume formula. Now, sometimes if you specifically have a rectangular prism, so we're going to say rectangular prism, P-R-I, we're going to shorten rec and prism, and we're talking about that volume. You've seen that a lot as length times width times height. So let's say that you had a triangular prism, you would need to use that area with the base times the height. But if you have a rectangular prism, it's really easy to just do length times width times height. And some of you have even made that mistake in trying to find surface area. You're finding volume when you do length times width times height, not surface area. Okay? Cylinders are also interesting. You also really need the exact same formula as above. So your cylinder is going to be the volume of the area of your base times height. Now think about why that actually is. I'm thinking about volume, all these things in my prisms and my cylinders, it's the base times the height. Well, it's almost like you're working your way up and you're stacking a ton of those bases on top of each other to get that figure. If I were you, I think you could actually figure out what the volume of a cylinder would be in a little bit more specific terms. So take a second, pause the video, see if you could actually create what your next one would be if you don't want the area of the base. Pause it, try it. And we're back again. So if I had the area of a base, the base of my cylinder is a circle, correct? And this is what your cylinder should look like. Since the base is my circle, I can find the area of my circle. The area of my circle is pi r squared. And then I'm multiplying it by the height. So the volume of a cylinder is just volume equals area of the base times h, and then volume equals pi r squared times height. A pyramid is where it gets a little more interesting because I'm not just stacking things anymore in a pyramid. Instead, I have these slanted sides. So pyramid, I guess, makes your life a little bit more difficult. You can't just take the area of the base and multiply it by the height. What it actually is the volume as length times width times height divided by 3. And this is where it's really interesting to think about. Length times width times height divided by 3. What does that look like? Well, my pyramid looks a lot like my prism. And as I'm looking at this, I'm saying to myself, interesting. So really, the volume of a pyramid is just the third of what it would be if I was actually looking at a rectangular prism. And it makes sense. Underneath that pyramid, right, you would either have a rectangle, and this is specifically a rectangular pyramid, just to let you know, rectangular, which is what we are going to be dealing with. So your base is that rectangle or your square, and then your prism's going up, and it's just a third of what that would be. So it gets interesting. Last one is cone. And I think this little, I'll come down a little. This little, I don't know how you would describe what this is. I don't know, picture, I guess, down here below with these 3 cones is really going to make it come to life what the formula for a cone is. So the formula of a cone, you might even be able to guess it according to that actual picture down low. This one is pi r squared times h divided by 3. You got that pi r squared times h divided by 3. Interesting, huh? You look underneath there. It takes 3 cones to fill up one cylinder that has the same base and the height. So it makes sense that the volume of my cone is just a third of what my cylinder would be with that base times the height. Okay, so here are your formulas. I hope that maybe explains a little bit of why they are the way that they are. Now, like always, you should be able to apply those. So I'm going to come down below. And as you can see, you have 4 problems for me. I'll do the first one with you. I think you're going to be like, oh, Miss G, but this is the easy one. Well, hopefully I can start you off on the easy one. Then you can be like, oh, Miss G. Okay, so I'm going to start with my length is 7. I'm going to start you then with the width is also 7. I always like using different colors. I think it just makes the picture pop. And then my height is also 7. My rectangular prism, we talked about this, is where I just take my length times my width times my height, which is 7 times 7 times 7, which is 7 to the third. So you're going to put that into your calculator. I'm typing it into my computer right now because I don't have my calculator handy, which I should. I'm a math teacher. And I have 343 as my volume. Now, we're going to put some units on this. I'm talking about meters, correct? You might recall that it's not just meters. I'm talking about 3 different values of measurements. I got my length, my width, and my height. So meters times meters times meters, or meters cubed to the third. And so this is my final answer. This is 343 meters cubed. Now, I kind of lied. I am going to start you off on this next one because if I had to guess, I'm going to get a lot of questions on it. Okay, here's where your life gets interesting. What kind of shape is this? Well, this shape that I'm looking at right here is actually a trapezoid, right? The base, it's a trapezoidal prism. The base of this, if I were to flip this upside down, is a trapezoid. I could see a lot of us going wrong here. There's my base right there. So instead of using length times width times height, because my base isn't just a rectangle, and that's the only time you can use that, and this is a trapezoidal prism, I'm going to have to find the area of my base first. Okay, and there's some helpful things, I think. You're going to have to kind of find your different measurements from different places in your picture. So remember, the area of a trapezoid is base 1 plus base 2. Times your height divided by 2. If you don't believe me, you can look it up. You can look and see what is the area of a trapezoid, and you should come up with that. So base 1 plus base 2 times your height divided by 2. Now here's where life gets interesting. What are those different measurements? Well, let's talk about our bases first. So we'll go bases, we'll underline them in yellow. Well, one of my bases of my trapezoid is already on the picture I drew, so it's 2.8. The other one, you're going to have to look over to that other side. You can see it over here. It's 8.1. Okay, so I have my two bases right there. I also have my height. It's found in another point of my picture. This is specifically the height for my trapezoid, not the height of my prism. That's where maybe you could go wrong. And now I have everything I need. So I'm going to say, okay, the area of my base is going to be 8.1 plus 2.8. And I'm multiplying that by the height, which we decided was 3, divided by 2. So here's another scenario where you probably want to pause this and use your calculator, making sure that you get the exact same thing as me, because this is where it could be easy to go wrong. Let's see, so when I add those numbers together, I get 10.9. I gotta multiply that by 3. So multiply it by 3, 32.7. And I'm going to take 32.7 and I'm going to divide it by 2. And I end up with 16.35. So that's the area of my base, which is my trapezoid. Now, the interesting thing about the 16.35, this is not my actual prism yet. That's just my base. I need to take this number, and remember volume is going to be area of my base. We can use a big B times height. Okay, so volume is going to be 16.35. Then I got to ask myself, what is the height of this guy? And I see this last number, then I can tell this height. We'll go ahead and we'll do it in purple. Here's my height all the way down that figure in purple, which is 12, so times 12. Okay, so 16.35 times 12 is going to be 196.2. So my volume is 196.2. And remember, I need my units. Oh, I don't even have units here. So that just means I'm going to use a U for units cubed. That's what happens if you just don't see any units of measure. So no inches, no centimeters, no meters, nothing like that. You can just use U cubed. And there's my final answer. So I can understand where this type of prism would be difficult, okay? So you just got to be really thinking, is this a prism, and then what's that type of base? These last two, the pyramid and the cylinder, I want you to try on your own. I think they're pretty straightforward. I think you got it. I'll be checking them. Remember that as I enter a grade, I usually say, sounds good. That means you got them all right. Or I'll be very specific about what you got wrong. If you do not finish these two, you will get a 2 out of 5. I'm going to really lay down the law on that one, because I've had some of you just finish these notes parts and then be like, I don't have to do the last two problems. I know how to do it. 2 out of 5 if you do that. Don't get lazy on me. You got 4 weeks of this left. I believe in you. You can do it. And that's what we're looking at. So if you have any questions, make sure you come on that Zoom meeting later. Oblique figures, we'll talk about this a little bit more tomorrow, so don't stress about oblique figures yet. But just finish those 2 problems for me, and we should be good. Have a great day.